Welcome back, everybody. This video is all about triangles and some of the attributes of a triangle. Before we do some examples, let's talk about just a few things about a triangle. One thing is called the Triangle Sum Theorem. And the Triangle Sum Theorems, all angles of a triangle sum to 180. That's important to know, especially when solving triangles. Maybe they give you two of the angles and you got to figure out a third. Well, if you know two of the angles, you can always figure out the third angle by just simply subtracting the two known angles from 180, because all angles of a triangle have to add up to 180. The other thing we want to talk about is the two sides of a triangle. Sum of any two sides of a triangle, it will always be greater than a third side. So sometimes you'll come across problems where they give you the three sides of a triangle, the lengths of the three sides, and it can only be a triangle if you take any two of those sides and guarantee that they are greater than the third side. If they're not, if you can take two and say they're less than or equal to, then it would not be a triangle. Okay. And then show another one here, just by an illustration. There we go. Let me connect this triangle here just to make it complete. There we go. Alright, so let's say we have a triangle here and the sides are 4, 5, and 7. And we know it could possibly work as a triangle. Look at the two smaller sides. Based on this statement here, the sum of any two sides of a triangle greater than the third. Look at the two smallest ones, the 4 and the 5. If we add those together, we get 9. 9 greater than 7, so we know this could work. But the thing I wanted to point it out, let's say we label the angles here. Angle A, angle B, and angle C. Alright, the largest angle is angle C. Angle C, because it's opposite of the longest side. So angle C would be greater than the measure of angle B, because angle B is opposite of the middle length. And finally, angle B and angle C would both be greater than the measure of angle C. Let me put little m's here to show measurement. Measure of angle B, measure of angle C. Alright, and I know my angle symbols are a little bit confusing with the greater than symbols. So, these are some things to know about a triangle as we do some examples here. Alright, let's look at this next one here. It says, on a piece of paper, use a protractor to construct a triangle with angles measures 40 and 60. What's the measure of the third angle? We can actually compute this without an actual protractor. Of course, there are ways to do that. You can create a triangle. Just draw a quick one here to see. Okay, one angle, 40. Another angle, 60. And then we don't know this third angle. Well, remember the sum of angles of a triangle have to add up to 180. 180 has to equal the sum of 40 plus 60 plus this unknown angle. Well, the unknown angle is, we'll just leave it as a question mark, 40 and 60 add up to 100. And then if we take away 100 from both sides, we get 80. So our missing angle is 80 degrees. Here, let's look at another one. Protractor to construct a triangle with angle measures 20 and 30. So I'll try to draw this the best I can. It won't be exact, like if we actually had a protractor. We could actually make it exact, but I'll just sketch it here. Again, we have 20 degrees, 30 degrees. Well, I'm just going to add those up and get 50. I know, just like the previous example, if I take 50 away from 180, I'll know this missing angle, and apparently it's 130. It's 130 right here. And what kind of triangle is it? Okay, well, there's three kind of triangles. All right. Talk about these really quick here. There's an acute triangle, where all the angles are less than 90. There's a right triangle, where exactly one angle equals 90. And then there's obtuse, where one angle, exactly one angle, is greater than 90. And if that is the case with our situation here, this example is an obtuse triangle, because you have exactly one angle that's greater than 130. All right, let's look at another one here. We'll have a multiple choice. Piece of paper, use a protractor and a ruler to construct two equilateral triangles. That means there are two angles that are exactly, they have all the sides the same, all the angles the same. One with a side length of 3 and one with a side length of 4. I can do a small model of that down here. All right, let's say, like I said, one side would be 4, one side would be 3. So which statement is true about the two triangles? All right, let's talk about these here. The two triangles are the same size and the same shape. Well, they're the same shape, but they're not the same size. So A is not going to work. D, it is impossible to construct equilateral triangles with these side lengths. No, I just did. We can do it. Let's look at B. The two triangles are the same size, but not the same shape. That is not true. The opposite of that is true. So C, the two triangles are the same shape, but not the same size. There's the true statement. Notice they have the same shape, but they're not the same size. One is bigger than the other. All right, a couple more multiple choice questions. Piece of paper, use a protractor to construct a right triangle this time. AB, triangle ABC. Go ahead and just kind of do a rough sketch of a right triangle. I know it's right if everybody can see that 90-degree angle here. There we go, and say angle A is apparently, there's our 90 degrees. Let's say angle B here, that's 45 degrees. All right, we know this to be 90. That's what the little box means. Angle C then would also need to be 45, because 45 plus 45 is 90. 90 plus 90 is 180. So that we know we have the triangle. And they say side AB is 4. AB is 4. Okay. Which statement is true about the triangles? There's AC. They're talking about AC and BC. Okay, well, we can't know for sure what side. We can figure out using Pythagorean theorem, but this BC we don't have enough information about. However, since these two, I know I didn't draw it right, but the two angles, since the two angles are the same measure, the opposite sides will also be the same measure. This AC side here will be 4, given that it's opposite of the angle 45, and since the other angle is 45 and has a side of 4, it too. So where we have B here, AC equals 4. Alright, and I'm going to draw this triangle a little bit better here. Yeah, it looks more like what I have here in green, with the two angles being the same, right here and here. That's more what this looks like, with side 4 and side 4. There we go. Alright, let's go one more here. Piece of paper, use a protractor to construct triangle ABC with angle A is 30, B is 60, C is 90. Which statements are true? Alright, let's try to get an approximation for how this might look. Similar to the one I drew before. There we go. Alright, we know angle, which is 90 degrees, and that is apparently angle C. The bigger angle, 60 and 30, 60 would be right here. That is angle B. And angle A would have to be 30 degrees. Notice that looks a little smaller. Alright, remember what we said on the very first slide about sides of triangles and their corresponding angles. The bigger the angle, the bigger the side. Okay, so let's say the opposite of angle C, I don't know, let's just call this the longest side. We can see it in the picture, and we also see its opposite, angle 90. Opposite of angle 30, the angle A here, this would be the shortest, and then B would be the middle of the way. We'll just call that mid, for it's midway between the longest and the shortest. It's less than, somewhere in the middle. Which statement is true? Or statements are true? Alright. B, let's just go through each one and say whether it's true or false. BC is less than AC. Since BC is the smallest, it would be less than anything. A is a true statement. The shorter side's less than the middle side. Statement B, BC is greater than AC. No, that's the opposite, so that one would be out. Statement C, BC would be less than AB. Yeah, BC is less than everything. So A and C here are definitely true statements. And then finally, BC greater than AB. No, the short is definitely not greater than the longest side. So there we go. Alright, hopefully these examples showed us a little bit more about triangles and they make a little more sense. Thanks for watching.